everyone, welcome back to Super Tutor Algebra. Today we're going to be learning about conic sections. So conic sections are sections of a cone. So we have cones here and we see that in the cone there are four shapes that are made. So we have a parabola which is made here, and we can see it will be also made here, made here. So it is a very essential shape in the cone. Circle is very self-explanatory. We see it here as well. We see it here with different radiuses. We also see lots of ellipses. So we have another one here. We can make one just here as well. We can make one here. So we see we have a lot of ellipses that make up a cone, and hyperbola, which is likely the newest one to you, is going to be two reflecting parabolas. So like we see we have that center line here, and we have one parabola going this way, one parabola going this way, and both parabolas approach one asymptote, two asymptotes actually that are exactly crossed. So in order to graph a conic section, we need to make sure that it is in the standard form. So the vertex form, standard form for parabola, is going to be y equals a x minus h plus k. For circle, it is y equals, sorry, x minus h squared plus y minus k squared equals r squared, where r is the radius. Ellipse is just like an oval shape, it's an elongated circle. So we have the equation very similar. It will be x minus h squared over a squared plus y minus k squared over b squared equals 1. It always has to equal 1, and the a and b squared will help us find the vertices of that circle. Now a and b can be interchangeable. A just refers to the bigger number, and that will tell us whether the ellipse is more vertically elongated or horizontally elongated. And now we have the hyperbola, which is very similar in the equation to the ellipse. It is x minus h squared over a squared minus, except y minus k squared over b squared equals 1, where a just refers to the one that is positive. So if this was a y major axis hyperbola, it will be y minus k squared over a squared plus minus x minus h squared over a squared, where the y will be positive and the x will be negative. So now let's start with graphing. Circle is the easiest to graph, so let's make up an equation in standard form. So maybe x minus 5 squared plus y minus 3 squared equals 9. So we know that the center will be 5 and 3, 5, 3. And the radius, the 9 refers to radius squared, so the radius will be 3. So let's graph 1, 2. The center will be here, and we will find 3 places in all 4 directions, and then we will just connect the dots. So here, 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 and here. And if we connect the dots, that is our circle. It's not drawing properly. I don't know what to do. Alright, let's try this. That's an ellipse, that's not a circle. Okay, that's better. That's our circle. Now let's try with the ellipse. Ellipse is also very simple. So let's make an equation. X minus 4 squared over 4 plus y plus 2 squared over 9 equals 1. Now first let's find the center. Same way as the circle, the center will be 4, negative 2. 4, negative 2. Alright, and in order to find the vertices, we have to take the square root of a squared and b squared. In this case, a is actually 9 because 9 is the great number, therefore this will be a squared and this will be b squared. 4 will be b squared. So if we want to, this tells us such it is a y major axis ellipse, and what we will do is we'll take the square root of both of these numbers. So 9 will be plus and minus 3, and we will go up and down 3 units from the center to find the vertices. 1, 2, 3, 1, 2, 3 here. And now for 4, we'll take the square root, which will be plus and minus 2, and these will be the co-vertices. And we will plot them 2 places, left and right from the center, and we will just connect the dots. Now let's try parabola. So the equation for a parabola is y equals, let's do x minus 9, no, x minus 6 plus minus 3, just to keep it a little bit more different. So we know that the vertex will be 6 minus 3, 6 minus 3. And we know that the axis of symmetry is going to be this in the parentheses argument equal to 0, which is x equals 6. Therefore we know that the axis of symmetry will lie right here. Now if you know the graphing pattern, you know how to graph this. It is a 1 3 5 rule, so you go one place to the left and right and one place up, then one place again and go 3 places up, and then 5, and then you keep going and with the odd numbers by 2 as many times as you want, but for this graph we'll just stop at 5. Otherwise you can also make a table and graph it like that. So this is our parabola graph, very simple. And lastly we have a hyperbola. This one is the one with the most components, so it can be a little difficult but not impossible. So x, let's make an equation, x minus 7 squared over 4 minus x plus 3 squared over 9 equals 1. So right away we know that the center will be 7 minus 3. And the same way we did with the ellipse, we're going to do it with, this should be y, sorry. We're going to graph it like the ellipse. So a squared is 4 and b squared is 3 is 9. So a will be plus or minus 2. And since it's on the x-axis, we will do it this way. Now we're going to do the same with b, which will be 9 plus or minus 9. And now we're just going to make a little box, like dotted lines. Now we have this box, we have a basic outline. Like I said before, hyperbolas will have two asymptotes going slanted. So from these 4 corners to the center, we will draw an asymptote, slant asymptote. And now we can graph the 2 parabolas. So since a is the positive one, we know that it will go to the x-axis, and this is how we graph our hyperbola. Many times you may have to find the equation of the asymptote, but you can just do that by using the slope-intercept formula. You take the center and one of these 4 points, find the slope, and that is your asymptote. So that is how to graph conic sections. I hope this video was helpful, and please subscribe. Thank you.